In this concept, we're going to talk about rate of change. Now, the rate of change is a rate that shows the changes of one quantity in relation to another quantity, right? So if we had something like, x and y, right? We can graph them or we can treat them algebraically. The rate of change is how they stack up against each other, how when one changes, the other behaves, okay? And there are different ways that the rate of change can manifest itself um, between two quantities. If the rate of change of the two quantities is positive, it means that when one of the two quantities increases, the other also increases. And here's an example. Income versus hours, right? So as one puts in more hours, they make more income, right? So this is a positive rate of change between income I and hours H, right? As the number of hours increases, the income increases. Another way that we can have a rate of change is if it turns out to be a negative rate of change. If it is negative, it means that when one quantity increases, the other quantity decreases. So there's like an inverse relationship between the two quantities. For example, we can have, something like temperature versus hours, right? You can think of this, as, the temperature during the day, for example, right? As the day progresses, as you go further into the night, the temperature decreases, right? So this is an example of a negative rate of change. Another manifestation of rate of change is when you get it when the rate of change of the two quantities is zero, right? And that means that when one quantity increases, the other does not change. Okay, so there's no dependence um, there's no increasing dependence or decreasing dependence between the two quantities. For example, here, as the hours increase, this temperature value stays the same. So in this case, the rate of change of this instance of temperature measurement with with time is zero. Okay, a constant rate of change. So the rate of change between any two data points in a linear relationship, right? So which is the graph of a line. This is a linear relationship, so this is a linear relationship, this is a linear relationship, this is a linear relationship, etc. This is a linear relationship. Any graph of a line that is a correct function of a line is a linear relationship. So the rate of change between any two data points in a linear relationship is constant. So the rate of change is constant, meaning it is some value, but it's a constant value. It's not a changing value over time or over the function. Okay, so we look at some examples of some linear functions, right? So we have the x and y axes coordinates, and then we have this sample line right here, and we could title these points A and B, for example, right? So, and then we could add another point here, for example, C, right? So the rate of change between A and C is the same as the rate of change between C and B, okay? Because it's a linear relationship. So the rate of change is some value, some known value, but it's a constant. Again, it's not a changing function. Same for this example. So a constant as opposed to what? Well, as opposed to a changing rate of change. So in the figure here, this is a non-constant rate of change, okay? Does not show a constant rate of change. So this is a changing rate of change. So for example, if we pick any, 3 points, so the rate of change between this point and this point, you even see that, this point did not go up too much to get to this point on the function. So the rate of change between these 2 points is not the same as the rate of change of this point in this point, right? You see the difference? Actually, from here, right, all the way up here, right? So you can see that this rate of change is non-constant over this graph, okay? And this is it for this concept. See you in the next video.